System of linear equations is given and we need to find the value of x and y using matrix method. First of all, as in the previous video we have learned, we'll make a matrix A with a coefficient of x and y of these two equations. So 5, 2, 7, 3, you can see matrix A found by the coefficients of x and y. Then another matrix X, variable matrix, in which the column will be written as variables x and y. If three variables are there, then we'll write x, y, z. And then third matrix, matrix B, in which we'll write the RHS of these equations, that is the constants in the column. So here only two equations are there, therefore only two elements are there. Okay, if three equations were there, we would have written three elements in this matrix. After that, already in the previous video, I have proved that A into x is equal to B. And since AX is equal to B, multiplying both sides by A inverse or pre-multiplying both sides by A inverse into A will be I, that is identity matrix. And identity matrix into any matrix is same, therefore I into x will be x. At the RHS on pre-multiplying by A inverse will get A inverse into B. And A inverse, what is A inverse? A inverse is 1 upon determinant A into adjoint A, right? So we need to find determinant of A. So determinant A in this case is 15 minus 14, that is 1. So since determinant is not 0, therefore we can find the value of x and y, or we can say value of this matrix X. After determinant A, we'll find adjoint A, and there is a shortcut of finding adjoint A. What is that? Exchange the values of this primary diagonal, that is instead of 5 put this 3, and instead of 3 put this 5. Okay, and sign change of these elements which is in another diagonal, right? So these are positive, these two are positive, so we'll make them negative. Here you can see. Okay, now so A inverse is 1 upon determinant A, and determinant A is 1, so 1 upon 1 into adjoint A. Adjoint A already I have explained. Interchange these values 3, 5 and change the sign of these values, and now finally we'll get matrix X, that is the value of x and y, and that is A inverse into B. This is A inverse, and B already I've explained what is B, and we'll multiply it following the rules of multiplication for matrices, that is row into column. 3 into 4 12, and minus 2 5 is minus 10. 12 minus 10 is 2. Similarly for second row, minus 28 plus 25, and that will be minus 3. So this first value is for x and the second value is for y. So x is 2 and y is minus 3. Quite simple. Now question number 8. Again, a system of linear equations is given. This time also we have two equations with two variables only, x and y. So we'll follow the same rule. First of all, matrix A with the coefficients of x and y, so 2 minus 1 3 4. So this is clear. Then matrix X, in which we'll write variables in column form, and matrix B, in which we'll write these constants which are at the RHS of the equations in the column form. Then AX is equal to B and x is equal to A inverse B, right? Now determinant is 2 4s are 8 minus 3, that is plus 3. So determinant A is 11. Now next step, to find A inverse we require adjoint A also. So 1 upon determinant A, 1 upon 11 into adjoint A. And how to find adjoint A for a 2 by 2 matrix? Just interchange these values. Here we'll write 4, here we'll write 2, so 4 2, and then change the sign of these elements, secondary diagonal. So this is negative, we'll make it, this is positive, we'll make it negative, this is negative, we'll make it positive. Okay, so inverse is 1 upon determinant A, adjoint A, right? Now x is equal to A inverse B. So this is the inverse, and B, as already stated, this is B. And now multiply following the rules, that is row multiply by column. 4 2s are 8 minus 8, and 1 3s are 3 minus 8 plus 3. Similarly 6 plus 6 12. So here we have minus 5 and 12, and outside we have 1 by 11. So multiplying this 1 by 11 with these two elements, so we'll get minus 5 by 11, that is the value of x, and 12 by 11, that is the value for y. So again a very simple question. Question number 9. Same question, same methodology. Okay, so first we'll make A, then X, then B, then same thing, determinant A, everything is same. I'm not explaining this question. If you have any problem in this question, pause it and then write it down, but my suggestions are do it by yourself. So without wasting the time, I'll just proceed to the next question. Next question again, we'll see two equations are there, two variables. So first of all, I'll make matrix A, which is the matrix made by the coefficients of x and y, then matrix capital X, that is variable matrix in which column is written as xy, and then B 3 5. Okay, the given system of equation can be written in the form of AXB. Now determinant A is 10 minus 6, that is 4. Thus A is non-singular, therefore its inverse exists. Once we'll do it. So A inverse is 1 by determinant A into adjoint A. You know that. Okay, so A inverse is 1 upon determinant A and adjoint A. And what is adjoint A? We'll just interchange these values. So here we'll write 2 and here we'll write 5, right? And then change the signs. So here we'll write minus 2 and here we'll write minus 3. Okay, so this is A inverse, and once you multiply this A inverse with this B, you will get X and Y. Okay, easy. So let me do this here for you. If you can do this, you can skip the video and then can learn how to solve 3 equations with 3 variables. But this is quite easy. Row into column. 2 3s is 6 and minus 10. So 6 minus 10 will be minus 4. And then minus 3 3s is minus 9. This row I am multiplying with this column. Minus 9 plus 25. So 25 minus 9. How much it is? 16. Right? And outside there is 1 by 4. So after we send this 1 by 4 inside the matrix, that is by multiplying it with 2 elements, I'll get minus 1 and 4. That is the value of x and y. Okay. Now question number 11. In this question, first time we'll see how to solve 3 equations with 3 variables. Right. So method is same. I'll make a matrix A with the coefficients of x, y, z, that is 2 1 1, first row, 1 minus 2 minus 1, second row. Here x is not there, so 0 3 minus 5, and then variable matrix, that is a matrix containing the variables in column, that is x, y, z in this case, and then matrix B containing these arches of these equations, that is the constants 1 3 by 2 and 9. And then we'll follow the same procedure. First of all, AX is equal to B, as we had done previously, and then determinant you can calculate it with respect to first row or first column, or whichever way you want to. I'll do it with first column, right? So first of all, writing this 2, then sign change the negative of 1, and then third element 0. For that I'll not do any calculation. So hiding this 2 by row and column, I'll get these 4 elements, and on solving I'll get 10 minus minus 3, that is plus 3. Then this, for this minus 1, hiding this by row and column, right, I'll get minus 5 minus 3, that is minus 8. So 13 2s is 26 and minus 8 into minus 1 is plus 8. 26 plus 8 is 34. So this is how we can calculate determinant, right? Already you know that. So right, so now we'll find cofactors so that we can calculate adjoint, compute adjoint, and then later on A inverse. So A11, okay, hiding this element by column and row, I'll get 10 plus 3, that is 13. Already here the cofactors are mentioned. You do it by your speed. I am doing to explain very slowly so that everybody can understand it. I'll hide this one by row and column. Minus 5 minus 0, that is minus 5. According to sign convention, later on we'll change the sign of this element. Hiding this one by row and column. 3 minus 0, that is 3. Similarly, I'll hide this element by row and column, so I'll get minus 5 minus 3, that is minus 8, and by sign convention later on I'll change the sign of this element. Currently I'm finding minus only, okay. Now hiding this element by rows and column. Minus 10 minus 0, that is minus 10 itself, and then hiding this element by row and column, I'll get 6 minus 0, that is 6. Later on change of sign. Hiding this 0 by row and column, I'll get minus 1 plus 2, that is 1. Hiding this 3 by row and column, I'll get minus 2 minus 1, that is minus 3. Later on change in sign to find cofactors, and then hiding this minus 5 by row and column, I'll get minus 4 minus 1, that is minus 5. So these are minors, okay. And now just simply change the sign of this element, right? If it is negative, make it positive. This element, this element, this element. So you will get your cofactors. This is positive, this is positive, this is positive, this will be negative, right? Once you get your cofactors, this first row you have to convert into first column, second row into second column, third row into third column, and then you'll get the adjoint also, right? So A inverse is 1 upon determinant A, determinant is 34, and this adjoint, as I have already explained, this 13 5 3 will be the first column, and then 8 minus 10 minus 6 will be second column, and then similarly 1 3 minus 5 will be third column. So this is A inverse, right? Already these things have been explained in the previous videos. So X is equal to A inverse B. A inverse is this, multiplying it with B, row into column. 13 ones are 13 and 24 by 2, that is 12, and 1 9s are 9, okay. Then second row, 5 ones are 5 minus 30 by 2, that is minus 15, and 3 9s are 27. And then last row, 3 minus 18 by 2, that is minus 9, and minus 45. Simply adding them up, and outside there is 34. 34 by 34 is 1, 17 by 34 is half, and minus 51 by 34, cancelling them by 17, 17 3s are 51 and 17 2s are 34. Final answer will get X, Y and Z. Question number 12. Again we have 3 equations, linear equations, and same process we will follow. So first of all, matrix A with the coefficients, I don't think there is any other explanation required for this. Matrix B will be 4 0 2, right? And matrix X is X Y Z as usual. So first of all, I'll calculate a determinant. I'll use first row this time. So 1, changing the sign of this minus 1, 1 again, then 1 again. Hiding this one by row and column, I'll get 1 plus 3. Hiding this minus 1 with row and column, I'll get 2 plus 3, that is 5. And hiding this one by row and column, I'll get 2 minus 1, that is 1. So 4, 5 and 1. It will make 10, right? And now the tougher part, that is finding the minors and cofactors. So first of all, I'll hide this one by row and column, and I'll get 1 plus 3, that is 4. Okay, then right, I'll hide this element by row and column. I'll get 2 plus 3, that is 5. So I'm finding minus later on. I'll change the signs. Hiding this 1 by column and row, I'll get 2 minus 1, that is 1. Okay, now hiding this 2 by column and row, I'll get minus 1 minus 1, that is minus 2. So this is minus 2 1. Hiding this 1 by row and column, I'll get 1 minus 1, that is 0. Hiding this minus 3 by row and column, I'll get 1 plus 1, that is 2. Hiding this element by column and row, I'll get 3 minus 1, that is 2. Hiding this 1 by row and column, I'll get minus 3 and minus 2, that is minus 5. And then hiding this 1 by row and column, I'll get 1 plus 2, that is 3. And then changing the sign of these elements. Kindly watch the previous video if you don't know these things, how to do all these things, right? Then this is the wastage of time. So now you have got the cofactors. I've shown you the calculations. Now first row, write it as first column, second row as second column, and third row as third column, and 1 upon determinant A into adjoint A. Determinant A is already 10, and this is your A inverse. And now x is equal to A inverse into B. A inverse into B, B already we know, this is B, right? And now we'll multiply. So row into column, 4 4s are 16, 0 plus 4. The next row, minus 20, 0, 10, see. The next row, 4, 0, 6, okay? 20 minus 10, 10. Divided by 10 means 2 minus 1, 1 is the answer. So this is the value of x, y, z. And now we have question number 13, a similar question. 3 equations, linear equations, we have to solve. So now again I'll repeat. First of all, make a matrix A with the coefficients of x, y, z, 2, 3, 3, 1 minus 2, 1, and 3 minus 1, minus 2. Then matrix A, variable matrix in which the column is these 3 variables. And then matrix B in which the column is these 3 constants at the RHS. Again we'll find determinant A. I'm using first row to calculate determinant A. First of all, write 2, change the sign of this middle term, write minus 3, and then 3. So this 2, when you write, hide this column also, this row also, and then 4 plus 1, okay, 5. Hiding this 3 by row and column, we'll get minus 2 minus 3, right? Minus 2 minus 3, and that will be minus 5. Then hiding this 3 by row and column, I'll get minus 1 plus 6, okay? So 4 plus 1, 5, 5 to the 10, minus 5 into minus 3, that is 15, and 5 3 is 15. So 10 plus 15 plus 15, it will make 40. So determinant is 40, not 0. If it is 0, then it is singular and A inverse can't be computed. So just following the same rules, hiding this 2 from row and column, we'll get 4 plus 1, that is 5. Hiding this element by row and column, I'll get minus 2 minus 3, that is minus 5. So these are minors. Again I'm repeating, I'll change the sign later on. Hiding this element by rows and column, I'll get minus 1 plus 6, that is 5. Then hiding this element by row and column, I'll get minus 6 plus 3. Minus 6 plus 3 means minus 3. Hiding this element by a row and column, I'll get minus 4 minus 9. Minus 4 minus 9 means minus 13. Minor 2 2. Hiding this element by a row and column, I'll get minus 2 minus 9. That is minus 11. Minor 2 3. And now last row. Hiding this element by a row and column, I'll get 3 plus 6. That is 9. minus 3 1. Adding this element minus 1 by row and column, I'll get 2 minus 3. 2 minus 3 is minus 1. And now hiding this minus 2 by column and row, I'll get minus 4 minus 3, that is minus 7, minus 3 3. Right. Now changing the sign of these four elements as usual, making negative positives and if positive negatives. Right. So right, everything is matching. Now first row will become first column, second row will become second column, third row will become third column. 1 by determinant A into adjoint A, this thing is called as adjoint A. So 1 by determinant A adjoint is A inverse. And finally X is A inverse B. So B we already know, here it is 5 minus 4 3. And now we'll multiply 25 row into column. Okay, calculation should be sharp. Already I am putting these videos of calculations, so watch them carefully, improve your calculation also. So 25 minus 12 plus 27. 25 minus 12 plus 27, right. Next. 25 plus 13 into 4, 52 plus 3. Right. Next. 25 minus 44 minus 21. Okay, and solving these terms, I'll get 40 80 minus 40, dividing by 40, I'll get my final answer. So this 14th question is there. I'll not solve it, do by yourself. Solution is here only. If you don't get the correct answer, come here again and watch this by pausing the video. Right. So let us not waste our times. Okay, now word problems. So I'll be putting another video word problems later on. Right. So here a simple one is there. The cost of 4 kg onion, 3 kg wheat and 2 kg rice is 60. Cost of 2 kg onion, 4 kg wheat and 6 kg rice is 90. The cost of 6 kg onion, 2 kg wheat and 3 kg rice is 70. Find the cost of each item per kg by matrix method. So cost of onion, 1 kg onion, let it be X. Cost of 1 kg wheat, let it be Y. And cost of 1 kg rice, let it be Z. Okay. So if 1 kg of onion cost rupees X, so 4 kg of onion will cost 4 into X. Okay. 1 kg of wheat if cost 5 rupees, then 3 kg of wheat will cost 3y rupees. And similarly, if 1 kg of rice cost rupees Z, then 2 kg will cost 2z. And that sum of all these costs is equal to 60. Similarly, from here I'll get 2x plus 4y plus 6z is equal to 90, and 6x plus 2y plus 3z is equal to 70. And now you are having 3 linear equations that we can solve by the same method that we have learned. So first of all, matrix A with the coefficients, then matrix X, right, and then matrix B with the constants at the RHS of the equations. Okay, so now determinant A first of all we'll find. So by the first row I am doing the calculation. Okay, so 4 minus 3 and 2, you can see. Then by hiding 4 by column and row, I'll get 12 minus 12, that is 0. Hiding this 3 by row and column, I'll get 6 minus 36, that is minus 30. And hiding this 2 by row and column, I'll get 4 minus 24, that is minus 20. So minus 30 into minus 3 is 90 and minus 20 into 2 is minus 40. On solving, I'll get 50. Done? Okay, so now it's turn to find minors. Let us see. So let me first erase this. Okay, now we'll find. So hiding this 4 by row and column, I'll get 12 minus 12, that is 0. So minus 1 1 is 0. Hiding this 3 by row and column, I'll get 6 minus 36. 6 minus 36 is minus 30. So minus 1 2. And now hiding this 2 by row and column, I'll get 4 minus 24, that is minus 20. So these are minus I am calculating. Later on I'll change the signs also. Now hiding this 2 by column and row, I'll get 9 minus 4, that is 5. Hiding this 4 by row and column, I'll get 12 minus 12, that is 0 again. And hiding this 6 by row and column, I'll get 8 minus 18, that is minus 10. So this is minor 2, 3. Hiding this 6 by row and column, I'll get 18 minus 8, that is 10. Minor 3, 1. Hiding this 2 by row and column, I'll get 24 minus 4, that is 20, sorry. And hiding this element by row and column, I'll get 16 minus 6, that is 10. And now I'll change the sign according to the sign convention. This element, this element, this element, and this element. Right? Simple pattern it is. This element, this element, this element, and this element. After that I'll write these elements in the column form, that is I'll do the transpose, and now I'll have adjoint A. So A inverse is 1 by determinant A. Determinant A already we see it is 50, and adjoint A from here we'll put. So now X is A inverse B, this is A inverse, this is B, multiplying row with columns. 0 into 60 is 0, minus 5 into 90, minus 450, 10 into 70 is 700, right? Next row, 30 into 60 is 1800, 0 into 90 is 0, minus 20 into 70 is minus 1400, and now last row, minus 1200, 900 plus, and plus 700. So on calculating them, we'll get 250, 400, 400 divided by 50. Finally, you'll get XYZ. So this is the end of the exercise. Do all the questions carefully. Keep studying. Bye-bye.